Okay, this example 4, it says find the zeros. Now, unlike the example in the book, they actually use the calculator, but I want to not use the calculator to just sketch the graph. It'll be close, it won't be exact. Find the zeros. Would you say this polynomial is in standard form or factored form? It's already in factored form, right? So when I say find the zeros, basically I'm saying what are the values of x that make that whole expression equal 0. And when it's in factored form like that, especially these factors, you can kind of tell just by looking. Right? What value of x would you put into this factor to make it 0? Positive 2. 2 minus 2 is 0. Right? What value of x would you put into that factor? Negative 1 plus 1. Right? What value of x would you put into that factor? Negative 3. Right? Those are the zeros. So there's 3 points that we know on this graph. Try to think of, we're not going to multiply this out. We know how we could do that. But we could tell the first and the last term very easily. There's going to be 4 terms. But the first term, if we were to multiply this out, will be x times x times x. X to the third, right? And it's positive. So we know that it'll be, the shape of the graph will be like that, correct? Okay, the last term will be negative 2 times 1 times 3. Negative 6, right? So plus, plus 6. And what does that represent? It's the y-intercept. So now we've got these 3 points, and we've got one other point. If I sketch this on a graph, yeah, it's negative 6. It's a negative, thank you. Which maybe draw that wrong. 1, 2, 3, 4, 5, 6. There's a point. And then here's 3 other points. Negative 1, negative 3, and positive 2. So we know this thing has a shape that's something like that. And just looking where those points are, it must do something about like that. Oh, come on. So we could understand that one just like that. What time is it? I think we got time. I'll save this one for later.